Problem number 6 stretches the limit. We now have 1/4 of a cycle of a sinusoidal curve, and we're being asked to find the equation for it. First thing I've done is put some extra numbers in there so we can do the measurements properly. The next thing I did was, using the little bit of a line we had, I put in the midline and the upper and lower bound. Now you might think, well, how did you know which side was where the midline went? Well, look at the curve. The curve on the bottom is flattening out and getting ready to go back to the other side. As it hits the intersection of 36 degrees and -60, it's going straight, or at least relatively straight, and it's not looking to curve at all, so that couldn't be one of the maximum points. The next thing I did was continue the curve. I probably didn't have to do that, but it makes it easier to see. And you'll notice that each one of these quarter of a cycle is a reflection or a transformation of the piece that they gave us. The one from 36 to 48 is a rotation of 180 degrees. The one that's between 12 and 24 is a reflection across the line at 24. And then again, the one that goes from 0 to 12 is a 180 degree rotation of the one that goes between 12 and 24. These are all things you can find from the one clue they gave you. Now that we have the two maximums, we can measure the distance between them, and that gives us the period. In this case, it's 48 degrees. Now, in order to find the b in the equation, we have to take 360 degrees and divide it by the period. That turns out to be 360 over 48, and it reduces to 15 over 2. The next thing we want to do is get the amplitude. That's the distance from the midline to the maximum or the minimum point. We can see on the left side the maximum's at -20, midline's at -60, the minimum's at -100. So it's 40 spaces from the maximum to the midline and 40 more spaces from the midline to the minimum. So that's the amplitude. Now, they've given us a measurement for the midline already, that's -60 degrees, and you'll notice there's no phase shift here, at least not if we're calling it a cosine curve, because it starts at the maximum and moves on from there. And this is the equation at the top that we are going to put all these numbers in to get the equation that we want. This is the form of it, the generic equation. First thing I'm going to do is take A, the amplitude, and put it into the equation, which is just outside the cosine function as a coefficient. And the next thing to do is to take b, 15 over 2, and put it in the equation where b goes. C, -60, the midline, put that where it goes. Basically, I'm just putting numbers in where the letters are. And since there's no phase shift, d just sort of disappears. And this turns out to be your equation. Y equals -60 plus 40 cosine of 15 over 2 theta. That's how to do that.